Okay, so in this lesson, we're going to learn how to divide a polynomial by another polynomial. Now, just want to remind you in the previous lesson, so recall the previous lesson where we talked about dividing a polynomial by a monomial. Now, remember, a monomial is still considered a polynomial. Now, when in the previous lesson we divided a polynomial by a monomial, remember what we did? So let's look at number 3. Let's remind ourselves. See, we have this polynomial being divided by this monomial. So we broke it down into separate fractions. Remember that? Each term in the numerator divided by the denominator, and then we just reduced each fraction, each rational expression. Okay, and then we got our answer. When you're dividing a polynomial by another polynomial, for example, something that looks like this. Okay, so you see how you have a polynomial, but this polynomial right here is not a monomial. So remember, if you have a monomial, you're asked to divide this polynomial by this other polynomial, and this polynomial here, notice, is a monomial, one term. Then you write as separate fractions, and then you reduce. In this case, though, you cannot do that. To do this, we're going to use what's called long division. Long division. Okay? So we're going to use what's called long division. Now, you've dealt with long division before, so let's remind ourselves about this idea of long division. All right, so let's talk about this. So this is a review of long division. All right, so number one, let's suppose we have 723 divided by 5. 723 divided by 5. Now, remember, the numerator is larger, greater than, equal to the denominator. So this is an improper fraction. All right, and so when you divide, remember when you divide this by hand, not using a calculator, when you divide this by hand, remember you said 5 divided into 723. So our division symbol right here. So that's the format you wrote this in. So there's a couple of words that you need to know at this point. You need to remind yourself of those words at this point. Remember, this 5 right here is called the divisor. The divisor. The 723 is called the dividend. Okay, so the numerator is your dividend, the denominator is your divisor. So remember, some students have a little bit of difficulty remembering what goes where. So your denominator is the first thing you write, your numerator is the second thing you write. So your denominator is your divisor, your numerator is your dividend. And that's going to be important. That's going to be important when we use long division with polynomials. Okay, so let's go. I'm going to go ahead and rewrite this over. So I'm going to say 5 divided into 723, and let's remind ourselves how we found the quotient. Remember that what we get up here is called the quotient. I'm going to write this in a little while, but that's called the quotient. So let's remind ourselves about long division. So this is what you said. You said 5 into 7 is 1, right? So 5 goes to 7 one time. Then you multiplied. You said 1 times 5 is 5. Now remember what you did next. Remember what you did next was you subtracted, right? So mentally you said 7 minus 5 is 2, correct? All right, so mentally you subtracted. And so then when you subtract, the next thing you did was you brought down the next term. And then you did the division all over again. So 5 will go into 22 4 times. 4 times 5 is 20, and remember you subtracted. So each time you get to that point, you subtract. So 22 subtract 20 is 2. And then you brought down the next term. And then you said 5 into 23 will go 4 times as well. 4 times 5 is 20. And then you subtract, you get 3. Now notice there are no other terms left, right? There's nothing else for you to bring down. So this final number you see right here, that's called the remainder. So that's the remainder. And this number right here is called the quotient. Okay, that's called the quotient. So your quotient is 144 and your remainder is 3. Now I want to remind you about different ways you could write this what we just found. So 723 divided by 5 can be written as 144, the quotient, plus the remainder divided by the divisor. So this right here, is the quotient plus the remainder divided by the divisor. And so remember when you're adding a whole number, and notice that this 3/5 is a proper fraction, right? Because the numerator is less than the denominator. And so remember you wrote this as 144 and 3/5. And you remember you always can check yourself, right? So if you said, and I'm going to use a calculator for this part because of our time, but if you said 5 times 144, 144 times 5, oops, yeah, you get 720, and then you said 720 plus 3, and you get 723, which is the numerator. All right. Okay. So remember this is your quotient. So that's your quotient. This right here is your remainder. And then you're always going to divide the remainder by the divisor, not the dividend, the divisor. That's important to remember. So this is your divisor right here. Divisor. Okay? And so when we start talking about dividing a polynomial by another polynomial, all these ideas here will come into play. Okay, now let's look at this for a moment. So let's suppose we had, let's say we had this. Okay, so let's suppose we had 192 divided by 6. And so I'm going to use that notation again. I'm going to say 6 divided into 192. So 6 is our divisor, 192 is our dividend. And remember what we did there, we said 6 into 19 is 3. 3 times 6 is 18, and then we subtract. 19 minus 18 is 1, and then bring down the 2. 6 into 12 is 2. 2 times 6 is 12, and when I subtract, I get 0. And notice there are no other terms to bring down, right? So 0 is our remainder. That's our remainder. And so as the answer, you would say 192 divided by 6 is 32, and that's what you said. So remember, if the remainder is 0, then it's just a whole number that you got. Here, though, when we did this, the remainder was not 0. The remainder was 3. So that's where you had this mixed number. You had a quotient plus a remainder divided by the divisor. And so the remainder of 0, remember with the remainder of 0, that means that 6 goes into 192 evenly. And so that's why you got a remainder of 0. Notice here, I did not get a remainder of 0, so 5 does not go to 723 evenly. That's why you did not get a remainder of 0. Okay, now let's talk about dividing a polynomial by another polynomial using long division. Now you're going to need, as we go through this, you're going to need these steps right here. So make sure you go to Canvas and you download these steps. And so as you go through this long division idea, then we're going to talk about these steps, and that's going to be important. Okay? All right, now. Okay, so long division, the reason we're learning long division, one of the reasons we're learning the idea of long division in polynomials is that it is important in factoring. It is can be used in factoring polynomials. It can also be used in finding zeros of polynomial functions, and it's also important in finding slant asymptotes, and we're going to talk about slant asymptotes at some point. But in finding slant asymptotes, which is a skill that's used in calculus. So that's one of the reasons why you're learning the idea of long division. So let's continue talking about our steps. So these are the steps that you're going to use when using long division to divide a polynomial by a polynomial. So I'm going to go ahead and write down our first problem, and then we're going to look at each of those steps. So number 1, And the directions will say something like this. So the directions will say divide using long division. Okay, divide using long division. So let's talk about our first one. So let's say number 1, we have x squared plus 7x plus 10 divided by x plus 2. Okay, now one of the things that's very important in step number 1, and make sure you see this, it says rewrite. You're going to rewrite this as a long division problem, which means you're going to write it like this. You're going to write it using this notation. That's what that means. Okay, so you're going to write your divisor and you're going to write your dividend. So that's what that means. So this right here, long division problem, means this idea, and you're going to go through these steps. Okay, so keep in mind though, still in step number 1, it says this: make sure that both polynomials are written in descending order, and you learned about descending order in previous courses. And then if there's any missing term, you're going to write it as a 0 term. Okay, so as we go through this example here, we're going to discuss all those words that we just mentioned. Okay, but let's talk about step number 1. So step number 1 says, I'm going to rewrite this using long division, and I need to make sure that each polynomial is in descending order. So remember, descending order means going from the largest exponent to the smallest exponent. All right, so notice that this exponent's a 2, this exponent's a 1, and then you have your constant right here with no variable. Okay, so your constant's always last. So this is already in descending order, and so is this. X to the first, and then your constant's last. Okay, and so it's going to look like this. You're going to say x plus 2 divided into x squared plus 7x plus 10. Now notice there are no missing terms. No missing terms, because listen carefully. Your largest exponent is 2, right? So I have an x squared. The next exponent is 1. Do you have an x to the first? Yes. And then your constant. Okay? If you look right here, your largest exponent is 1, and then the next thing is your constant. So no missing terms. All right. Now we're going to do a problem where there are missing terms, but this one has none. Okay, so remember we did when we did this. So when we started dividing, we said we're going to take the divisor, which is 5, and divide it into that first number we saw, which is 7. So 5 into 7 gave us 1. The same idea here. So you're going to divide the first term of the dividend by the first term of the divisor. And you're going to place that quotient above its like term. All right, so here's what I mean. So first of all, locate the first term of the dividend. So the first term of the dividend is x squared. So this is, I'm going to put step 1 right here. So this is step 1. I'm sorry, step 2, excuse me. So this is step 2. So this was step 1 here. This is step 2. So you're going to take that first term, which is x squared, and divide it. So mentally in your mind, and you don't have to write this out. Most students will just go through these steps here. We'll go through these steps and then just write them out, because they'll be doing this mentally. Okay? But in your mind, this is what you're doing. You're saying x squared. So you're going to take the first term here, divide by the first term of the divisor, which is x. And so x squared divided by x, remember when you divide like bases, subtract exponents, so x squared divided by x is just x. All right, so that's your quotient at this point. Now, remember, it's very important that you put this over its like term. So you see how this is x to the first? So put it here. Put it right here where you have all the x's aligned, all the x squared aligned, and all your constants aligned. That's important. It does help. So I'm going to put x here. All right, now, remember what we did here. I'm going to go back to right here. So when I said 5 into 7 is 1, remember the next thing we did was we took this 1, multiplied it by the divisor, right? So 1 times 5 is 5. This is what step 3 is saying now. So step 3 says multiply that quotient from step 2 by the divisor. And you're going to place the product below its like term. So in other words, you're saying this. You're saying right here, your quotient. So you're going to say x times x plus 2. So in your mind, see, this is what you're doing mentally. So mentally, you're saying this, x times x plus 2. So the quotient, this term here, times the divisor. And then make sure you distribute. So x times x is x squared. X times 2 is 2x. And you're going to put that here. Make sure you align your like terms. So put the x squareds on each other and the x's on each other. So again, let's kind of review. So step 2 says I take the first term, first divided by first. So x squared divided by x is x. So that goes here in your quotient. Then you're going to multiply this times your divisor. So x times x is x squared. X times 2 is 2x. All right, so you do this mentally. All right, now here's the next important thing. Remember when we did this? When I said 1 times 5 is 5, what was the next thing I did? The next thing I did was I subtracted, right? 7 subtract 5 is 2. The same idea here. So that would be your step 4. So step 4 says subtract and bring down the next term. So let's remind ourselves what we did. 1 times 5 is 5, and then I subtracted. 7 minus 5 is 2, and then I brought down the next term. All right, so that's what this step 4 is saying. Okay, now listen carefully. This right here was just numbers. These are terms, polynomials, terms. These were just numbers. And so when I subtracted, that was only one thing to subtract. 7 minus 5 is 2. Correct? Here, though, you're subtracting two terms. So it's very important to be careful. Be very careful. So here's what I'm going to do. I'm going to use a red pen here. And then I'm going to do this. So I'm going to subtract. Now be careful. You're subtracting all of this. Okay? You're subtracting all of this. And when I subtract all of that, now you're going to do this mentally. And I want you to think about this. You're saying x squared subtract x squared, right? And then you're going to say 7x subtract 2x. Okay? Just like you did this. Just like you did this. You said 7 subtract 5, right? Then you said 2 subtract 2, correct? Then you said 2 subtract 2, and so on. I'm sorry, you said 22 subtract 20, you got 2. Run the next term. And then 23 subtract 20, you got 3. The same idea here. If you're doing this correctly, this first term should always go away. And it will. If you're doing this correctly, it will. So now what we get is this. 7x subtract 2x is 5x. And then you bring down your next term. Okay? So let's go back over this step again. So that's step 4. So step 4, you subtract and bring down the next term. So this right here is your step 4. You subtract all of this and then bring down the next term. All right? So this is bring down the next term. So when I subtract, I say x squared subtract x squared is 0. Okay, those cancel out. 7x subtract 2x is 5x. All right, and now you're going to repeat steps 2 through 4 until you brought down your last term. And that's what we did here. I want you to notice. So let's talk about this. So 5 goes into 7 one time. 1 times 5 is 5. Subtract, bring down the next term. And then we repeat the next steps all over again. 5 into 22 is 4. 4 times 5 is 20. I subtract, bring on the next term. Repeat all over again. All right? And we repeat it until there were no other terms to bring down. See, there no other terms to bring down, so that was your remainder. And so that's what this step 5 is saying. So step 5 is saying now you're going to go back and you repeat all these steps again until you brought down the last term. All right, so let's talk about that. So now we're going to remember step 2. Step 2, repeat steps 2 through 4 all over again. Step 2, remember said this. Divide the first term of the dividend by the first term of the divisor. So now this is your dividend because you're saying this divided to this. So now this is your dividend. So you're going to say 5x. You're going to say 5x divided by the first term. So 5x divided by x is 5. And that goes here. So remember, that's a positive 5, right? So you're going to say plus 5. And then you're going to say 5 times this. 5 times this. Not this times this 5 times this. That's important. 5 times this. So in your mind, you're saying 5 times x plus 2. And so that becomes 10x, 5x plus 10. So it becomes 5x plus 10. Okay? And now I subtract. Now when I subtract, I want you to notice what happens. 5x minus 5x is 0. 10 minus 10 is 0. So I'm going to put a 0 here. And notice there's no other terms to bring down, so that's your remainder. That's your remainder. And so you're going to write your answer as this. You're going to say x squared plus 7x plus 10 divided by x plus 2 equals the quotient. And then since there's no remainder, that's all you write. So this divided by this is this. Okay? And I want to remind you about something. So remember, you can always check this. You can always check. So let's talk about this right here, though. So right here, remember what we did was to check. Remember what we did to check was we said 5 times 144 plus 3, right? 5 times 144 plus 3. So basically what we're saying is this times this plus the remainder better give us 723. 5, the divisor times the quotient plus the remainder better equal the dividend, correct? All right. So basically, so let me remind you about this. Let me write it out. So the dividend, 723, will equal the divisor times the quotient, divisor times the quotient, plus the remainder. Okay? So the dividend, right here, the dividend will equal the divisor times the quotient plus remainder. So let's see if that's true. So let's just check this. So let's check. So here's your divisor. Here's your quotient. So that's your quotient right here. That's what you just found. So x plus 2 times x plus 5, and you want to see if that's going to equal the numerator, the dividend, x squared plus 7x plus 10. So notice I'm multiplying two binomials. I'm going to use a FOIL method. X times x is x squared. The outer is 5x. The inner is 2x. And the last is 10. And when I combine like terms, I get x squared plus 7x plus 10, which is what we had. Okay? So this is correct. That right here is your quotient. Remember, no remainder, so that's your quotient. Okay? All right, so that's number 1. Now let's look at number 2. Now, the more problems you do, by the way, the more problems you do, the easier this long division becomes, and you don't have to keep looking at this. The more problems you do, the better going through these steps, the better you are at going through the steps and actually not looking at these any longer. Okay? So it's very important you do as many of these as possible. And you do not have to check at the end. Just keep that in mind. You do not have to check at the end. But if you have time, it's a good idea to do that because it does provide you practice with multiplying polynomials. Okay, so let's look at number 2. Number 2, let's suppose we had this in number 2. All right, so it's going to be number 2. Let's say we had this one. We had now sometimes the directions may say, you see how the directions said this right here, divide using long division, and look like this. Okay, the directions could also say this. The directions could say divide x squared plus x minus 12 by x minus 3 using long division. Okay, so just notice it could be stated in several ways. So this, dividing this by this, means the same thing as this. Okay, so in other words, you can say, well, I'm going to rewrite this as x squared plus x minus 12 divided by x minus 3. All right. Okay, now remember step 1 is to rewrite this in long division form. keeping in mind that we need to put this in descending order, and any missing terms we're going to write as 0 term. All right, so I want you to notice, though, that this polynomial is already in descending order, and so is the polynomial right here. So, and there are no missing terms. I have an x squared, I have an x term, I have my constant. I have an x term, and I have my constant. Okay? So then we're going to say x minus 3, which is our divisor, into our dividend, which is x squared, plus x minus 12. So we're going to do another easy example, and then we're going to look at some where this coefficient here is not a 1. And the coefficient here is not a 1 either. Okay, so remember, the second step, divide the first term of the dividend by the first term of the divisor. And you're going to place the quotient above its like term. So what you're saying is this, x squared divided by x. So x squared divided by the first term of your divisor, which is x, becomes x. X squared divided by x is x. So I'm going to put this x right here. Then we multiply. Remember that? We multiply. So this times this. So in your mind, you're saying x times x minus 3, which we know is x squared minus 3x. So that goes here, x squared minus 3x. Now you got to be careful. So remember, the next step is to subtract. Subtract and bring down the next term. So you're saying this, you're subtracting all of this right here. Okay, that's important. It's important you see that. You're subtracting all of this. So in your mind, you're saying x squared minus x squared is 0. That's all supposed to go away. Every time you do this, I want you to see this. Every time we repeated those steps, see how x squared minus x squared is 0, and then 5 minus 5x is 0? That's how it's supposed to look. Okay? So x squared minus x squared is 0. Now be careful here. X subtract a negative 3x. Some students have difficulty with that idea. So what some students like to do, and it's up to you, is right below that, basically, remember when you're subtracting a polynomial, all you do is just changing the signs. So this becomes a negative x squared, and then the opposite of a negative 3x is a positive 3x. All right, and that's all you're doing. And then you just add your terms. X squared and negative 3x squared is 0. X and a positive 3x is 4x. Okay? So if you need to, if you're having trouble saying x, mentally saying x subtract a negative 3x, then just rewrite it right here. And then you just add like terms. So remember, this is what you're saying. You're saying x, once you see this, you're saying x subtract a negative 3x. Okay, x subtract a negative 3x, which becomes x plus 3x, which is 4x. All right, so different ways of looking at it, of writing it. All right, so you can write it like I did in the red right here, or you can think about it mentally like this. But sometimes, for some of you, it may be helpful to actually write it out like I did here, so you don't mess this up. Because once you mess up one of these terms, then your quotient is going to be incorrect and your remainder is going to be incorrect. Okay, so that's important. And then the end, if you don't check, then you will not see that you did not make an error, or that you did make an error. Okay, so let's go through this again. So first divided by first is x. Then you're going to multiply this term that you just put in the quotient by the divisor, all of the terms of the divisor. X times x is x squared. X times negative 3 is negative 3x. Then you subtract. Okay? Now remember, x minus x squared is 0. So that's why you don't see anything here. And then x subtract the negative 3x means x plus 3x, which is 4x. And then you bring down the next term. Okay? And then you do the division all over again. You do all those steps all over again. So 4x divided by x. So 4x divided by x, in your mind, that's what you're thinking. And so 4x divided by x is 4, and that goes here. Positive 4 goes here. And then you take this term you just put, multiply by your divisor. So 4 times x is 4x. 4 times a negative 3 is a negative 12. And then you subtract, just like you did. Okay? Now 4x minus 4x, that's 0. And it just turns out that a negative 12, subtract a negative 12, means negative 12 plus 12, which is also 0. So remainder is 0. Okay. And again, if you have to, then write it out. So subtract, and basically when you subtract this polynomial, you're just changing the signs. So the opposite of 4x is a negative 4x, and the opposite of negative 12 is a positive 12. And now notice 4x and a negative 4x is 0. See, all these, just like we were talking, this cancels out always. Your remainder is not always 0, just happens to be 0 in our previous two problems. And then negative 12 and a 12 is 0. So your quotient is x plus 4, and remainder is 0. So you would say as your answer, you would say x squared plus x minus 12 divided by x minus 3 is going to equal x plus 4. Okay, that's your answer. All right, and if you check real quickly, if you just go ahead and check, so remember you're going to say this, your divisor times your quotient plus the remainder is going to equal the dividend. And so since the remainder is 0, basically all you're doing is just saying x minus 3 times x plus 4. Okay, and you want to see that's going to equal the dividend, which is x squared plus x minus 12. And so if I FOIL this, x times x is x squared, the outer is 4x, the inner is a negative 3x, and the last is a negative 12. Negative 3 times 4 is a negative 12. Combine like terms, I get x squared. This is positive x, and minus 12, which is what we wanted. Okay? Now, let's look at number 3. Number 3, let's suppose we had this for number 3. Okay, number 3. All right, let's suppose we had, so we can do this by long division. So I have x cubed minus 4x minus 3 plus 2x divided by x plus 2. Okay, so let's suppose we had that. All right, so remember, step 1, and so the more problems you do, the easier it is to remember all this. So step 1, remember, you're going to rewrite this in long division, making sure that both polynomials are written in descending order, and any missing zeros, you're going to put a 0 term. So notice though that this polynomial is not written in descending order. Okay, so remember the largest exponent you see is 3. So I'm going to go ahead and rewrite it here. So, and then the next one, oops, I'm sorry, I meant this to be right here, excuse me. I meant this to be right here, x squared. So then the next one is x squared, right? So minus 4x squared. But notice the next term you better put here is the x term. Your constant always goes last. So I'm going to have to change this order here. So this is plus 2x and then minus 3. Now it's in descending order. X cubed, x squared, x, and your constant. And this is already in descending order, x plus 2. Okay? Now we're going to put this in long division form, x plus 2. And by the way, there's nothing missing. X cubed, there's an x cubed term, there's an x squared term, there's an x term, and a constant. Okay? So you can say x plus 2 divided into x cubed minus 4x squared plus 2x minus 3. Okay. Now, let's go ahead and do the long division. So I take the first term of the dividend divided by the first term of the divisor. So x cubed divided by x becomes x squared. I'm going to take that x squared, I'm going to line it above the x squared here. So that's x squared. Now remember, the next thing is to multiply. So now we're on step 3. So multiply that quotient by step 2, which is your divisor. So x squared times x plus 2. Okay, so in your mind, this is what you're saying. You're saying x squared times x plus 2, which is x cubed plus 2x squared. So that goes here. Align your like terms. X cubed plus 2x squared. Okay, now remember the next thing you're going to do, is you're going to subtract all of this. So mentally, and most of you are able to do this mentally. So mentally, you're saying x cubed subtract x cubed. If you do this correctly, this is always going to cancel out. And then you're going to say negative 4x squared. Now, this is where you got to be careful. A negative 4x squared subtract 2x squared. So if you need to rewrite it, you rewrite it. So So you're going to rewrite this right here in red. So the opposite of x cubed is a negative x cubed, and the opposite of a positive 2x squared is a negative 2x squared. And then you're saying a negative 4x squared and a negative 2x squared is a negative 6x squared. Okay, so let's remind ourselves what we did. So if you need to rewrite this, just like I did here, then you go ahead and you do that. Okay, some of you though don't have to rewrite it. Some of you can say in your mind, some of you are going to say negative 4x squared subtract 2x squared. Negative 4x squared subtract 2x squared. And a negative 4x squared and a negative 2x squared is a negative 6x squared. And that's what we had here. All right, then you bring on the next term, plus 2x. And then you do the division all over again. So you take the first term here, divided by the first term here. So you're saying negative 6x squared divided by x, which is a negative 6x, right? Negative 6x. We divide by basis, subtract exponents. And so we put this negative 6x right here. See, I line my like terms. And then you multiply all over again. Negative 6x times x plus 2. So in your mind, you're saying negative 6x times x plus 2. So, and you don't have to write this like I'm doing here, because in your mind, you know you're saying negative 6x times x. Negative 6x times x is a negative 6x squared. And then, so negative 6x squared. And then negative 6x times 2. Negative 6x times 2 is a negative 12x. And that goes here. And then remember, the next thing you're going to do is you're going to subtract now. See, subtract, subtract. Every time you get to this little point here, you're going to be subtracting. I want you to notice, though, that negative 6x squared, subtract the negative 6x squared, that's 0, right? And some of you don't see that. So if you don't see it, I need for you to actually write it out like this or put it in red. So you're saying this. You're saying negative 6x squared, subtract a negative 6x squared. Negative 6x squared, subtract the negative 6x squared. So remember, when you subtract the negative 6x squared here, that means 6x squared plus 6x squared, which is 0. So if you need to, put it in red. Put it right here. So you're subtracting this polynomial right here, so you're changing the signs. So negative 6, the opposite of a negative 6x squared is 6x squared. The opposite of a negative 12x is a positive 12x. All right? And so a negative 6 squared and a positive 6x squared, that's 0. Now over here, we have this now. We have 2x subtract a negative 12x means the same thing as 2x plus 12x, which is 14x. And then bring on the next term. Okay? And then you do division all over again. So you can take 14x divided by x. So 14x divided by x. And so 14x divided by x is just 14. And so that's going to go over the constant. So that's plus 14 right here. So you take that 14 now and you multiply by your divisor. 14 times x plus 2. That's what you say in your mind. 14 times x plus 2. And so 14 times x plus 2 is 14x plus 28. So 14 times x is 14x. 14 times 2 is a positive 28. And then you subtract. Just like that. 14x minus 14x, that's 0. So you see how at every little pair here, the first always cancels out? Okay? Now be careful here. A negative 28 subtract 28. So what that means is this. So if you need to rewrite it in red, you rewrite it in red. So the opposite of 14x is a negative 14x. The opposite of a positive 28 is a negative 28. I want you to notice a negative 3 and a negative 28 is a negative 31. Okay? So negative 3 subtract 28 is a negative 31. Now notice, I want you to notice, there's no other term to bring down, right? So that's your remainder. Okay, that's your remainder. All right, so when there's no other term to bring down, when you don't have any other term to bring down, you're done. That's your remainder. Now the question is this. In the previous two examples we did, the remainder was 0. And so we saw that for the answer, all we did was wrote the quotient. That's all we did. Okay? I want to remind you about something. When I go back and talk about this, when we looked at this, so remember here we had a remainder, right? And so when I wrote the answer, it was the quotient plus the remainder divided by the divisor. The quotient plus the remainder divided by the divisor. Okay, so basically you're saying this. You're going to say, since I have a remainder of negative 31, you're going to say the answer will be, and let me go ahead and write down the problem. So here's a problem. You had x cubed minus 4x squared minus 3 plus 2x divided by x plus 2 is going to equal, so we divide these two polynomials, you get the quotient, which is this, okay, x squared minus 6x plus 14 plus the remainder, which is negative 31, divided by the divisor, which is x plus 2. And that's your answer. So the quotient plus the remainder divided by the divisor. And that's how you write your answer. So when they say, when you're asked to divide these two polynomials, it's always your quotient. And if you have a remainder that's not 0, then you're going to have to write this fraction. You have to write the remainder as a fraction. The remainder divided by the divisor. Okay? All right, now, let's go ahead and check this. I want to go ahead and check this. Okay, so I'm going to go ahead and check this. Now, let's remind ourselves about how we checked this before. So I'm going to go back to that very simple example we did here with the numbers. And so to check, remember what we did, we said, you see when we did this, we said 5 times 144. So we said the divisor times the quotient plus the remainder. So 5 times 144 plus 3. Okay? So when we did this, we said so to check, put that here, you said the divisor times the quotient plus the remainder equals the dividend. Okay? And so the divisor, remember, is 5. So 5 times 144, the quotient, plus the remainder, is going to equal 723. So here we have the divisor. And so here's the way I'm going to write this. So I just rewrote this right here. This right here is right here. So the divisor, which is x plus 2, times the quotient. So x plus 2 times the quotient plus the remainder. And you want to see if that's going to equal this. You want to see if that's going to equal the dividend. Okay, so this times this plus this has to equal this. All right, so let's do that. Now be careful here. So notice that these are not two binomials. That's a binomial times a trinomial. So we have to use the distributive property here. So remember how to do that. You're saying x times all of this first. So x times x squared is x cubed. X times a negative 6x is a negative 6x squared. X times 14 is 14x. And then you did the 2. Then you distribute the 2. 2 times x squared is 2x squared. 2 times a negative 6x is a negative 12x. 2 times a positive 14 is a positive 28. And then you're going to add a negative 31. Okay? Let's combine like terms. X cubed, I have a negative 6x squared and a positive 2x squared is a negative 4x squared. So far it looks good, right? And then a positive 14x and a negative 12x is a positive 2x. I'm looking good so far. And then your constants right here, and positive 28 and negative 31 is a negative 3. So this is correct. So when I divided this polynomial by this polynomial, either one does not matter, I got this answer, and that's the answer, because when I multiplied this times this and added negative 31, I got the dividend back. Okay? All right, so that's number 3. Now, let's do one more. And we're going to do one where there's a missing term, because I want to do one where there's a missing term. And then in the next lesson, I'll just do some more examples, um, just like we did here, just in case you need more examples. So let's look at a problem where there is a missing term. All right, so let's look at this one now. So we have, so we're dividing these two polynomials, and we're going to do this long division, using long division. And so notice though, this is in descending order, x cubed, x, and then your constant, and this is in descending order as well, x to the first, and then your constant. The problem is, now notice in step 1, filling in missing terms with a 0 term. Okay, so notice I am missing a term because listen, the largest exponent is 3, right? So the next one should be x squared. I don't see an x squared at all. I do not see an x squared at all. So that's my missing term. I see an x and I see a constant, but I do not see an x squared. So I need a missing term. So when I do that long division, I'm going to have to write in that missing term. Okay? And the reason it's important, let me remind you, the reason it's important is because of this alignment. So you remember we put all the x cubes together, we aligned all the x squares, we aligned all the x. See how they're all aligned? They're all aligned, right? That's important. Aligning your like terms are important, especially when you do your subtractions. Okay? So notice when I do this alignment, there's an x squared missing, so I need it. Now the question is, how do you put it in there? Okay, so the way you're going to do it is this. So you're going to say 2x minus 1, which is your divisor, divide into your dividend. So you're going to say 4x cubed. I'm missing x squared, so I got to say 0x squared, because 0x squared is still 0, right? Okay, so you got to have a 0 there. 0x squared, and then plus x, and then plus 10. So that's how you put your missing term. So your missing term is called your 0 term. So whenever you put your missing term, you're going to write as a 0 term, okay? Because 0 times x squared is still 0. And so 0 plus all of this is still this right here. All right, so let's do the long division. So now you know how to do the missing term. And you can have more than one missing term, by the way. Keep that in mind. And in our next lesson, the next lesson that goes with this, I'll do one where there's like 2 missing terms. Okay, so remember we said the first divided by the first. So 4x cubed divided by 2x. So 4x cubed divided by 2x. So 4 divided by 2 is 2. X cubed divided by x is x squared. So you can line your like terms. See the reason why you needed this? So 2x squared. So you put your x squareds over each other. Then you multiply. 2x squared times 2x is 4x squared. So remember, this is what you're saying. You're going to multiply this times your divisor. So 2x squared times 2x minus 1. So in your mentally, this is what you're doing, right? So that becomes 4x squared, 4x cubed. 2x squared times 2x is 4x cubed, and then 2x squared times negative 1 is a negative 2x squared. And that's what you're going to put here. So 2x squared times 2x is 4x cubed, and then 2x squared times negative 1 is a negative 2x squared. Now remember at this point, that's where you subtract and then brought down the next term, okay? So you got to be careful though when you subtract. You're subtracting all of this. So 4x cubed minus 4x cubed, that should always go away. So remember our pattern. Always remember our pattern. You see the pattern? Cancel, cancel, cancel. Okay? Every little pair here, every little pair you see, first thing you did was cancel. And it happens here as well, because 4x cubed minus 4x cubed is 0. Now be careful here. 0x squared subtract a negative 2x squared. Some students get a little bothered by that. So if you have to, then put in this little put in the equivalent expression right here. And I'm doing it in red. I mean, you could still do it in your pencil. So the opposite of 4x cubed is a negative 4x cubed. And the opposite of a negative 2x squared is a positive 2x squared. And then you're saying this. You're saying 4x cubed and negative 4x cubed is 0. 0x squared and a positive 2x squared is 2x squared. And then you bring on the next term, plus x. And then you do the division all over again. Do that process all over again. Remember, you repeat steps 2 through 4. So you're going to take the first term here, 2x squared. divided by 2x. Well, 2x squared divided by 2x is just x. So that's going to go here. And then you take this, you multiply with the divisor. So x times 2x is 2x squared. X times a negative 1 is a negative x. Okay? And now you're going to subtract. So 2x squared minus 2x squared, that's 0, right? Now be careful here. Be careful here. That's x subtract a negative x. So be careful. So if you have to, put it in red or put the equivalent expression right under it. The opposite of 2x squared is a negative 2x squared. The opposite of a negative x is a positive x. So remember we said x subtract a negative x. So x subtract a negative x means x plus x, right? Which is 2x. So x plus x is 2x. So you got to be careful. Then bring down the next term. And then you do it all over again. So 2x, put that here, 2x divided by the first term of your divisor, 2x. So always go back to that first term of your divisor. Well, 2x divided by itself is 1, right? So that's going to go here, plus 1. And then you're going to say 1 times your divisor. So 1 times 2x is 2x. 1 times a negative 1 is a negative 1. Now remember, you're going to subtract. Remember, you subtract at all these points right here. And if you do this correctly, this better cancel out just like the rest did. 2x minus 2x is 0. Now be careful here. See, that's 10 subtract the negative 1. So think, 10 subtract negative 1, which means 10 plus 1, which is 11. So if you have to, rewrite it right here if you have to. The opposite of 2x is a negative 2x. The opposite of a negative 1 is a positive 1. And then you see 10 plus 1 is 11. And notice there's nothing else to bring down. There's nothing else to bring down, so you're done. Okay? And so your answer, you're going to say, I'm going to rewrite this. So you remember you're dividing this, right? So you're saying 4x cubed plus x plus 10 divided by 2x minus 1 is going to equal the quotient, so 2x squared plus x plus 1 plus the remainder divided by the divisor. So plus 11 divided by 2x minus 1. And so there's your answer right here. Okay, so this equals the quotient plus the remainder divided by the divisor. All right. Now, I'm gonna check this in a little while, but one thing I got to remind you. So remember when in a previous lesson, in one of our previous topics, we talked about the degree of a polynomial. And I want you to notice the degree of this polynomial here is 3. So remember the largest exponent, since these are just one variables in each term, the largest exponent is 3, so that's your degree. Here the degree is 1. So remember, you keep on dividing when the degree is greater than or equal to the degree of the divisor. So the degree of the divisor is 1. So remember we said that you stop when there's no other term to bring down. Well, technically the reason why you're not going any further with the division is because of this. See, the degree here, the degree of a constant is 0. The degree of a constant is 0. And 0, and the degree of your divisor here is 1, because x to the first, the degree here is 1. So 0 is less than 1, so you're done. Okay? So notice here, see right here, the degree of this polynomial is 2. 2 is greater than the degree here, so I keep on doing the division. So in our next lesson, when we talk about these again, we're going to bring up that idea. But I just wanted to keep that on your radar, that the degree here is 0, and so since 0 is less than the degree here, which is 1, you cannot go any further, you're done. So that will be your remainder. All right. Okay, now let's go ahead and quickly check this. I want to check this just to show you how to check this. So let's go ahead and check this. So we're checking. So let's check. let's check that 4x cubed plus x plus 10 divided by 2x minus 1 does equal 2x squared plus x plus 1 plus 11 divided by 2x minus 1. So let's check that. So what we did, so to check it, you're going to say your divisor times your quotient. Remember, that's your quotient. So the divisor times the quotient. The divisor times the quotient plus the remainder has to equal the dividend. And the dividend is 4x cubed plus x plus 10. All right. Now notice this is a binomial times a trinomial, so I can't use the FOIL method, cannot use the FOIL method here, so I've used the distributive property. So you're saying this, cover the -1 for right now. So you're saying 2x times all of this. So 2x times 2x squared is 4x cubed. 2x times x is 2x squared. 2x times 1 is 2x. Okay, then let's do the -1. Distribute the -1 now. -1 times 2x squared is a -2x squared. -1 times x is a -x. -1 times 1 is a -1, and then our remainder. Combine like terms, I get 4x cubed, 2x squared, and a -2x squared, that's 0. Okay, so you see there's no x term here, right? 2x and a -x is a positive x. There's my positive x. And then a -1 and a positive 11 is a positive 10, and so that does equal. All right, so you check. So what I have here is correct. So this polynomial divided by this polynomial will equal this quotient plus this remainder divided by the divisor. Okay? All right, so that is how, let's see, let me go back to that first page. So that is dividing a polynomial by a polynomial. And in the next lesson, I'm going to do some more problems with dividing polynomials, just to show you some other things you could see. But this lesson is just a basic introduction to using long division to divide a polynomial by a polynomial.